Hello and good afternoon my dear kids. Welcome back once again to this short tutorial video for class 7 students under the topic exponents. Okay, since we are doing the topic exponents, so this video will be the continuation of the previous video. The topic was your exponents, isn't it? Okay, for those who haven't gone through the previous video, please go through the previous video as we have discussed a few important basics of the previous video as well. Okay. So now, before going on to the sum study, what I want you to do is, I want you to copy the laws of these exponents as well as memorize it. Now, how will you memorize and how will you memorize it and how will you read it out is simple. See, laws of exponents we have here: e to the power m into e to the power n equals to e to the power m plus n. So what is happening out here? See, actually we are multiplying two exponential forms with same base. See, the base are same, a and a, isn't it? The powers are different, so the base are same, the powers are different, and the relation is multiplication. E to the power m into e to the power n, so it will be equal to e to the power m plus n. The base will remain same. What will happen? Simple, the powers will be added. Okay, and the second one what we have here is e to the power m into b to the power m. So the expansion will be a into b whole to the power m. That is, when the bases will be different and the powers will be same, the relation multiplication, all we need to do is multiply the base, the power will remain same. E to the power m into b to the power m equals to a into b whole to the power m. This is how it is read as. Also, this is how you need to memorize it as well. Okay, now for the third one we have here e to the power m divided by e to the power n. See, the same thing, this one I have written in the fractional form and this one I have written using the symbol. It's same as, it is read as same, isn't it? E to the power m divided by e to the power n will be equal to e to the power m minus n. That is, two exponential forms with the same base, different power, and if the relation is division, two exponential forms with the same base, the relation different exponent, and the relation is division. At that time what happens? The powers will be subtracted, and remember, always the power of the numerator comes first. Okay, numerator, the power of the numerator. See, that is why we have written e to the power m minus e to the power n. Okay, and similarly in this one, number 4, e to the power m divided by b to the power m. See, the fractional form, here I have written it using a symbol. E to the power m divided by b to the power m. The expansion, the formula is, it will give us a by b whole to the power m. That is, when we have two exponential forms with the relation division with different base and same power, what happens? We need to divide the base, the power will remain same. Okay. Now the fifth one, what do we have in the fifth one is e to the power minus m. Now remember, this one is very important as well. Okay, e to the power minus m will be equal to 1 divided by e to the power m. Now, or 1 by e to the power minus m equals to e to the power m. Now, as soon as you know this term, as soon as you have watched now this form, now what happens is, now you cannot leave your answer with a negative exponent. That is a negative power. Remember that. Now you cannot leave your answer with a negative power. What happens is, for negative power we need to now reciprocate the term. Simple, reciprocate it, the power will change its sign. Simple. See, e to the power minus m, when reciprocated it give me 1 by a to the power m, a positive m. See the denominator, isn't it? All you need to do is simple reciprocate the term. See, 1 by a to the power minus m equals to e to the power m. But remember, this reciprocal is applicable only when your power is negative. Your exponent is negative, not the base. Remember that. Okay, only when the power is negative, then only it is applicable. Okay, and the sixth one we have here is e to the power 0 is equals to 1, or what you can say is anything to the power 0 is 1. Anything, remember, no matter how big the number is, if the power is 0, that means you can directly simply write your answer as 1. Okay, and if the power is not given, now listen very carefully, if the power is not given, remember the power is always 1. I guess I have discussed that earlier in the earlier video as well, isn't it? If the power is not given, that means the power is 1. So that is why we cannot consider, if the power is not given, we cannot consider it as 0, because what happens if the power is 0? It will change to 1 directly. Anything to the power 0 is 1, remember that. Okay, now the last law, that is e to the power m to the power n. That is, when we have two exponents, there is two powers, what happens? Simple, see, e to the power m n. This is how it is read as. E to the power m to the power n will be equal to e to the power m n. That is, whenever you are writing two variables together, you know the relation, isn't it? The relation is multiplication. So e to the power m to the power n will give us e to the power mn, m into n. That is for two powers. If the exponential form has two powers, all you need to do is simple multiply the powers. The base will remain same, multiply the powers. That's it. Okay. Okay, so let's do a few sums. Then you may get to know. Okay. For exercise 4b, I have taken from exercise 4b. So question number 1, 3. So in question number 1, 3, what do I have is 2 to the power 10 into 2 to the power 4. So I have got exponential forms, two exponential forms with same base, different powers, and relation is multiplication. So which one will be applicable? Simple, this one will be applicable, isn't it? E to the power m into e to the power n equals e to the power m plus n. See, two exponential forms, relation multiplication with same base, different powers. So what am I supposed to do? Add up the power. So see, 2 to the power 10 plus 4, 2 to the power 14. See, and once you get to know this law, you no need to show this second line. Okay, you can directly go from question to answer, 2 to the power 14. Okay, because we know that 10 plus 4 is 14, isn't it? Then why need to show it? Okay. Okay, now this one. Oh, yeah, question number 4. So let's go with question number 4. Question number 4, what we have is 6 bracket 6 to the power 5. Now what we know is bracket means multiplication, isn't it? And for this 6, the power is not given. So remember, just remember, just a few seconds earlier, what did I say? If the power is not given, then the power is always 1. You cannot consider it as 0, isn't it? As I've already said, if you consider it as 0, then anything to the power 0 will be equal to 1, isn't it? So that is why the power of 6 in here is 1. So see, 6 to the power 1 into 6 to the power 5. Now again, e to the power m into e to the power n, e to the power m plus n. So 1 plus 5 is 6. See, I haven't written the 1 plus 5 line, isn't it? You can skip that part. Okay. So 6 to the power 6. That's our answer. Okay. And the fifth one in here we have is e to the power 7 bracket e to the power 3 bracket e to the power 4. We know that bracket means multiplication and all. That means it actually means what? E to the power 7 into e to the power 3 into e to the power 4, isn't it? Again, see, I haven't mentioned that line. I haven't shown you that line, because what we know is the bracket means multiplication. What is happening out here? Multiplication of exponents with same base. The powers will be added, simple. And I haven't shown the line where I have added the power as well. See, what do I know is 7 plus 3 is 10, 10 plus 4 is 14. So I have directly written the answer, C, e to the power 14. Okay, this is also how you can do it. Okay, but for that you need to memorize the exponents. Remember, memorize the laws of exponents. Now what I want you to do is, I want you to write the laws of exponents in your copies as well as memorize it. Okay. Okay, now for question number 7, what do I have is the fractional forms. See, 1 by 5 to the power 5 into 1 by 5 to the power 2. Again, exponential forms, relation is multiplication, base same, two different powers. So the base remains same, so base 1 by 5, 5 plus 2 is 7. So we are done here, see. Okay, no need to do anything, isn't it? It's just that the base is in the fractional form. Okay, again this one. The question is minus 5 by 9 to the power 4 into minus 5 by 9 to the power 12. Now what do I know is two exponential forms with same base, though the base is in fractional form, isn't it? With same base and relation is multiplication, the powers will be added. That's what I know, e to the power m into e to the power n. So that is what I have done here. See, minus 5 by 9 whole to the power 16. Now for this one, in this one I have written it as 5 by 9 to the power 16. That means both the answers are correct. Why so is because, see, a negative sign with a even number exponent. What did I say? A negative sign with a even number exponent will change its sign, isn't it? So either you leave your answer up to here, or you directly write your answer as this one, that is 5 by 9 to the power 16. Both are correct. Okay, but remember, this only happens when your exponent is a even number. Okay. Now the 11th one, that is 4 by 9 to the power 3 into 4 by 9 to the power 6 into 4 by 9 to the power 11. See, three terms are there: multiplication, same base, different powers. What is the thing? The exponents will be added, isn't it? The base will remain same. So 4 by 9, 3 plus 6 is 9, 9 plus 11 is 20. So 20, done. See, easy one, isn't it? Okay. So moving on to the next one we have here is, what do I have here is question number 2, 3. I have here as 10 to the power 5 to the power 2. Now what have I said? For two different exponents, that is two powers, what did I say? I have already written the formula, isn't it? E to the power m to the power n is equals to e to the power mn, that is, the exponents will be multiplied. So do I need to show the multiplication? I guess no, isn't it? Because simple, you know that 5 into 2 is 10. So that is why I have written, see, simple, 10 to the power 10, done here. Okay, similarly here, see, minus 2 to the power 3 whole to the power 4. It is read as this, say, minus 2 to the power 3 whole to the power 4. You got two powers in here, again the powers will be multiplied. 3 into 4 is 12. Now see, the base is minus 2 to the power 12. We know what we know is negative number integer with a even number as exponent. The sign can change, the sign will change, not can, will change, isn't it? So it is simple. You can write it as either as 2 to the power 12, or if you leave your answer up to here also, it's correct. Okay, or for those who have written directly answer up to here, from question to here, it's correct, because you know all you need to is just multiply the powers when you have two powers, isn't it? Okay. Now for the fifth one, again the same thing. See, 1 by 10 to the power 6 whole to the power 2. So 6 into 2 is 12. The base remains same, 1 by 10 to the power 12. So that's it. Okay. 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 So till here for this video, Okay. So I hope you kids have understood. Okay. For those who haven't, please do let me know, and stay tuned in for more videos. Okay, and what I want you to do is, I want you to practice the sums and the remaining sums from your book. Okay, and what I want you to do is, I want you to copy this exponents, this laws of exponents in your copy. Okay, I want you to write it down in your copies and memorize it as well. Okay, so till then, stay tuned, stay safe, bye bye.